What is up everyone, my name is Sagar and we are back here with another video, and this is the lecture number 10 of our Java and DSA course. And in the previous video we learned about the syntax of for loop, so today we are gonna practice problems on it. So without making any further ado, let's get started. So from the previous lecture we have that practice problem, that is a factorial of a number, and let's do it. So first I will create a new Java class, lecture 10. So this is factorial. So what is factorial of a number? In our previous video we find the sum of all numbers from 1 to n using a for loop and also using a formula. And factorial is the multiplication of all numbers from 1 to n, or we can say n to 1. So let us see the previous lecture. Here you can see we are finding the sum of all numbers and storing it in a variable. So let's also create a variable here that will store our factorial, and it will be 1. Because if the initial value of our factorial is 0, then we are multiplying all values, then multiplying with 0 will be 0. So we are initializing it with 1. And after that we have for loop. Statement 1 is initialization. So our numbers will start from 1. And after that statement 2, and it will be condition I is less than equal to n. So we will multiply all numbers from 1 to n including n. So our statement 3 will be I plus plus. We are incrementing all numbers from 1 2 3 up to n. So first we have to define n. Let us take that from input. So in our previous program, to find sum of all numbers, we are adding all numbers to our sum variable. As you can see here, sum plus equals to I. So here I will represent all of our numbers from 1 to n, and we are adding every number to our sum. So here in this case we have to find factorial, and factorial means multiplication. So we will multiply I to our factorial. Factorial equal to factorial multiply I. You can also write it as this, factorial multiply equals to I. So this is the same thing, we learned that. And now let's print it as out factorial. Let's run this. So here suppose n is 3, so factorial will be 3 into 2 into 1, that is 6, and it is 6. Suppose my value of n is 10, so factorial will be this. So this is the one way we can write this. We are starting from 1 and incrementing it every time up to n. And we can also write it as, we can start from n and we will keep decrementing it up to 1. So let's write this. Our I will start from n and I should be greater than equal to 1, and every time I will decrease. So let's run this. So factorial of 3 was 6, and it is. So after this, let's move to our next problem, which is a famous series, not a web series, and that is Fibonacci series. Let me tell you what is that. We have this 0, 1, 1, 2, 3, 5, 8, and so on. So this is Fibonacci series, but we still don't get it. So let us analyze this. So you can see here, this is 0 and this is 1. So these are the first two numbers that we have to remember. Our series will start from them. So 0 and 1, and after that this is 1. So this one is the third number, and this will be the sum of previous two numbers. So 0 plus 1 will be 1, and after that we have this 2. So this 2 will be the sum of previous two numbers. 1 plus 1 will be 2, and after that we have 3. This is also the sum of previous two numbers. So 1 plus 2 is 3, and again 2 plus 3 will be 5, and 5 plus 3 will be 8. So in this problem we have to print numbers from this series. Suppose if we are given some n, that will be 4, so we have to print first 4 numbers. that is 0, 1, 1 and 2. So let us take integer input int n equals to sc dot next int. So how can we do it? Let us see that. So in order to find any number, we should have previous two numbers. So we will just store previous two numbers. Suppose my first number will be a, that is 0, and second is b. So we know first two numbers, that will be 0 and 1. So first we will just print them as out a and b. And after that we have to print all the remaining numbers. So suppose we are given n equal to 4, so we have to print 4 numbers, but we already print 2 numbers, so we just have to print n minus 2 numbers. So our loop will start from 1 and it will go up to n minus 2. N minus 2 because we are already printing 2 numbers outside of our for loop. So what will be our number? That is the sum of previous two numbers. So we will store it in a variable c equals to a plus b. So c will be 1 because a is 0 and b is 1. So let's print that c, and after that we also have to update these two numbers a and b, because when we are printing this c, so this c is 1 and b is also 1, so we have to move ahead. So our a will be now 1 and b will be now also 1. So after one iteration we have to move ahead, then a will store the value of b. So a equals to b. As you can see here, currently this is a and this is b, so this one will be c, and then we have to move ahead to find our fourth number. So this will be a and this will be b. So a equals to b and b equals to c. B equals to c. So this a will now hold 1, which was previously 0, and this b was previously 1, which was our second number, but this time it is our third number. So let's run this. Suppose our n will be 5. So you can see here, this is 0 and this is 1. So these are the two numbers that we already know and we are printing them outside of our for loop, and the sum of this number 0 plus 1 will be 1. And after that we have to move ahead, and then we have to take these two numbers 1 plus 1 and the sum will be 2. So after that we have to again move ahead, then 2 plus 1 will be 3. So let's print 100. So you can see here it is going out of integer range. Let's try to print first 10 numbers, and you can see here 3 plus 5 is 8 and 8 plus 13 is 21. So that is it. So that's how you can print Fibonacci series, and there is nothing complex in this. This is very easy. You just have to find a pattern and you can just code it out. Implementing your logics into coding will be a piece of cake after you practice this thing. So you just have to practice, practice and practice, and you can then code anything. The main part will be logic building and finding any pattern. So after that, now moving ahead to our next question, and that will be series sum. So let us first comment this. So we have to find the sum of our series, and the series is 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by n. So this is just a straightforward question. We will create a variable that will store our sum, and sum can start from 0. Sum should start from 0. We can't initialize it with 1. So we have to write a for statement that will start from 1 and I will be less than equal to n and I plus plus. So same in this question, we have to find sum of first n numbers. So n will be from input, and we just have to add the number to our sum. So sum plus equal to, what we have to add? We cannot add I because I is an integer and it is 1, 2, 3, 4, 5. But here you can see in this series it is 1 by 1 plus 1 by 2 plus 1 by 3. So we have to add a floating number, then 1 by 2 will be 0.5 and 1 by 3 will be something. So we can also find a pattern here. You can see here this denominator is the same. Here it is 1 and it is here 1, 1 and 1. Every time it is not going to change. So we can write it as it is 1 divided by, and this denominator is starting from 1 and increasing every time. You can see here this is 1, this is 2, this is 3, up to n. So we have to add 1 by I. So here I will act as our denominator, so it will start from 1 and go up to n. So that means at first iteration it will be 1 by 1, that is 1, and after that I will be increased by 1, so it will become 1 by 2, and we are storing every number in sum. So let's print it, sum. So suppose I want to find the sum of first two numbers, that is 1 plus 1 by 2, and that is 1.5. So n will be 2, but our output is 1. And this is because you can see here this sum variable is an integer type and it can't return 1.5. So when we are adding 1 by 1, it will be 1. So sum will be 1, and when we have 1 by 2, it will add into sum and it will remain 1. So 1 plus 0.5 will be 1.5. So it should return 1.5, but it is returning 1 because here our sum is integer and it will downcast this floating value, that is 1.5, to 1. So we have to make this a float variable, float. So then it will have 1 plus 1 by 2, then it will be 1.5. Let's run this. So n was 2, and again this is a problem. It is printing 1.0. This is a floating value, but it is not the correct answer. Let's check it. So you can see here there is some yellow highlight, and let's float over it. You can see here 1 by 0 integer division in floating point context. Now that means here this I is integer and 1 is also an integer. So integer divided by integer will return an integer. So 1 by 2 should be 0.5, but it is not returning 0.5. It is returning 0. So this I should also be a floating number. Float. And you can write here 1.0 or 1. This is the same thing. It will upcast this one, and 1 will be also a floating number. So I will just write here 1, and let's run this. Hope this time it will give correct answer. So n was 2 and the result is 1.5. Let's check it for another case. Suppose our n was 5, so it is returning 2.28 something. So you can see here in this problem we have to mind these things, that what is a float number, and we are adding a float number to an integer, or we are dividing a float number. So we have to mind all these things. Here at first we have to return a floating number, so our sum should be also float. And in our sum variable we also have to add small values like 0.5, 0.3, so they should also return a floating value. So 1 by 2 will return a floating value when both of these are 1. So I will be also 1, and this 1 will be also upcasted to floating value. So this will act as 1.0, and this is the same thing, but here it is automatically upcasting because here our I is a floating number. So after this, now let's move ahead to next problem. First I will comment all this. This was series sum. We did Fibonacci, factorial, and after that we have prime number. So we all know what are prime numbers, that do not have any factors. That means they are only divisible by themselves and 1. And example of prime numbers are 7, that is only divisible by 7 itself and 1, and also 5, and also 3, and also 11, and so on. So this problem can be of two types. One type can be we have to find whether a number is prime or not, and the another type can be we have to print first n prime numbers, like first prime number is 2, and then second is 3, and then 5, and then 7, and then 11, and so on. But today we are only going to solve the first type. you can try the second type and solve it by yourself, but don't worry, we will be doing it in our upcoming video. So the first type is find whether a number is prime or not. So how can we do it? We are only given a number. Let us suppose that is 9. How can we find whether it is prime or not? We know that if it is not prime, then it will have some factors. And in our example, we have 9. 9 have factor of 3. So 9 is not a prime. But suppose we have 7. So we don't know whether it have any factor or not. So we will check every number from 1 to 7. And if any number is dividing 7 from 1 to 7, that means 7 have a factor and it is not prime. So we have to move from 1 to 7. So first I will have n from input, and then I will start a for statement from 1. Number should be less than n, because if number is equal to n, that is 7 equals to 7 and it is dividing 7, so we don't have to do that. So we will go from 1 to 6 and then I plus plus. And there is also one thing to notice, that we are starting from 1. That doesn't make any logic. 1 can divide any number, so why are we counting on that? So we will start from 2. So how can we find whether a number from 2 to 6 is dividing 7 or not? And the answer is by using modulo operator. Modulo operator returns us the remainder. If we are dividing 7 with 2, then the remainder is 1. So 7 modulo 2 will be 1. And we know that if after dividing two numbers the remainder is 0, that means this number is divisible by that. So we have to check 7 modulo 2 whether it is 0 or not. So 7 is our n and modulo 2. 2 is here our I. So if the remainder is 0, that means I is a factor of n, and then n is not a prime number. So I will print not prime. But after this for loop, if any number is not dividing n, that means n is a prime number. So we have to write prime number. But this statement will be printed every time after the for loop ends. So we have to create a check, and that check will be, we will create a boolean variable that will tell whether our number is prime or not. So this boolean variable will be first true. That means we are assuming that our number is prime. But if we are entering in this statement, that is n modulo I double equals to 0, that means the remainder is 0, then it is not prime. So we will write here prime equals to false. That means our number is not prime. And after that we will create a check. If prime equals to true, only then we will print our statement. Let's run this. If our number was 7, then it is a prime number. If we have 89, then it is also a prime number. So this program is now working fine, but it is still not complete. First, see, we have to print this statement, our number is prime, only after checking all numbers. That means after our for loop. But in our program, every time after our loop ends, it will print this statement, without knowing whether we found some number that is a factor. So even if the number was not prime, we were still printing the statement, but we are using here a flag. Now flag means we are using a variable that will keep the track of whether our number is prime or not. So we are using here a boolean variable, and first we are assuming that our number is prime, so our flag will be true. But suppose if our number is not prime, then we will enter in this statement. This statement will be true. Suppose n is here 6 and our I is 2. So 6 modulo 2 is 0. So our number is not prime and we have to print the same. But we have to also tell our flag that our number is not prime anymore. So our flag will be now false. So you can see here this flag is false and we are printing not prime. And after the for loop ends, we are checking that if we have flag true, then only we have to print that our number is prime. But this is not completed yet. Let's run this. Suppose our n is 6. So you can see here it is printing not prime 2 times because 6 have 2 factors, 2 and 3. So when our I is 2, this condition is true and it will print not prime and our flag is false. and after that I is increased by 1 and I is 3, so this condition is again true because 6 modulo 3 is also 0. So our prime flag will be again false. This will make no change, but it will again print this statement. So what can we do here? We can just use a break keyword. We already used this break keyword in our switch statement video. If you don't know about this, you can check out that video, playlist link in the description. So we will enter in this block and our prime is false and we will print number is not prime, and after that we will break from our for loop. Now that means we don't have to check further for 3 and so on. So this is also another method to get out of loops. And once we hit this condition, that means some number is a factor of n, and that means flag is false and we are breaking out after printing that our number is not prime. And if we never hit that condition, that means there is no number that is a factor of n. So this prime flag will be never false and it is true. So we will enter in this block and we will print our number is prime. So now let's run this. Suppose our n is 3, 3 is prime. Suppose my n is 21, it have factor of 7 and 3 and it is not prime, it is only printing one time. But suppose my n is 1, then it is printing prime. But 1 is not a prime number, so we also have to consider that case. So this is called as base case. So there are some base cases that we have to handle at the start of our program. Like here we have n equals to 1. If n is 1, then it is a kind of exceptional case. So we can print not prime. So if our n is 1, then we are printing not prime. But still, if our n is 1, then this condition will be executed. Our flag prime is also true. And after this for loop, this condition will be also true. And it will print prime. Let's check it. If n is 1, here we are printing. Here you can see if n is 1, we are printing not prime. You can see here it is printing not prime. But because of this flag, because it is true, then we are printing this statement also. Because this condition is true and we will print prime. So how can we modify it? You can see if n is 1, then we have to do else. You have to do rest of the stuff. So you can put this whole program in this else block. You can see here now your program is completed. If n is 1, then it is not prime. If n is 2, then it is prime. If n is 3, then it is a prime number. So there are a lot of concepts in this, but it is also an easy program. Let me tell you one cool thing, that we don't need to check from 2 to n minus 1. Instead, we can just move up to root n, because if there is any factor of n, then it will be less than or equal to root n. Let me show you an example. So suppose my example is 35. Then the factor of 35 is 5 and 7. And the square root of 35 is around 5.9. So it will be taken as 5. So we will start from 2 and instead of moving up to 35, we will just move up to 5. Because if there is any factor, it will be equal to or less than root 35. So root 35 is here 5 and our factor is equal to root 35. So I will start from 2. 2 is not a factor of 35. So it will be 3 and then 4 and then at last it will be equal to root 35. Root 35 will be integer 5 and 5 is a factor of 35. So we will break after that. So how can we find root of some number? So either we can use an inbuilt method that is in math class. So math.sqrt and then here n. So this math is a class of java.lang package and this sqrt is a method to find some square root of some number n. But we will not use it here. We will use I square less than equal to n. If we suppose root n is equal to some number I, then I square will be equal to n. root of n. If it is equal to I, then it can be written as n equals to I into I. So we will do here the same thing, I into I, that will be I square, that is less than equal to n. So this is the same thing, I is less than root n. We have to use here less than equal to n because the factor can also be root n. Suppose in our example we have 49, then under root 49 is 7 and 7 is a factor of 49. So we will move from 2 to 7. We also have to check 7. So let's run this. Suppose our number is 49, then it is a not prime because it have a factor, that is 7. And if 7, then it is a prime number because root 7 will be 2 point something and it will be considered as 2, and 2 is not a factor of 7. So after that, if we have 35, then it is not prime because it have factors 5 and 7. So we will move from 2 to root 35. Root 35 is 5.9. So it will be considered as 5. So moving 2 to 5, 5 is a factor of 35. So that is a cool thing that you should remember. This will optimize your code. First we were moving from 2 to 7 to check whether there is a factor or not. But here we are only moving from 2 to root 7 and that is also 2. So it is an optimization. So this was a very cool program to find whether a number is prime or not. You can practice all these things by yourself. Try to optimize this code a little more and let me know in the comment section. So that is it for today everyone. Hope after this video you can solve all these questions. And now it is time for practice problem. So today in task 10, your very first step is to take one integer input, that is n. And then using for loop you have to print the sum of first n numbers from the given series. And the series is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6. In today's video we did the same problem. You can see here this series sum 1 by 1 plus 1 by 2 plus 1 by 3. We are using here float and this I is also float, but here we are always adding our number to sum. And in today's problem you can write it as 1 by 1. You have to check every time, either you have to add or subtract. So you will start from 0, then you will add this, then you have to subtract this, and after that you have to add this 1 by 3 and then subtract 1 by 4 and then add, then subtract. So you have to check every number and then perform accordingly. As I told you, coding the thing is not difficult, but finding the pattern is the main thing. So you just have to find a pattern here and you are good to go. Do share your answers in the comment section, and the first one to comment the answer will get a huge shout out in the upcoming video. And if this video is helpful, go hit that like button and subscribe to our channel, and also share your views in the comment section, and I will see you in the next one.